So this is video to go over the last note sheet for your packet of notes to take with you for next year. So first of all, you want to write down the situation that's described here. The tile pattern has 11 tiles in figure 4 and 8 tiles in figure 3. So remember, we used to work a lot with tile patterns. This is a very generic situation, but it is a linear situation, and that's why we're going to use it to make our graph, table, and rule. So let's start with a table. Our table has X and Y, of course. And one thing you hopefully were recently learning is that X is the independent variable. And remember, that means that it does not depend on anybody. Y is always the dependent variable. Y depends on X. So once I know X, I can find Y. And that shows up again in my rule. Remember, your rule is Y equals mx plus b. Y depends on X. X is in the rule to describe Y. And remember, we plug numbers in for X to find Y. So let's finish up this table and add the values that we have. We have 11 figure tiles in figure 4. 11 tiles in figure 4. So we got to remember which one's the independent, which one's dependent. So we think about it in two ways. First of all, we can read it. Is the number of tiles dependent on the figure, or is the figure dependent on the number of tiles? In this case, the first statement is true. The tiles in the figure are dependent on what figure number we are. The bigger the figure number, maybe there'll be more tiles, depending on the rule. So X is going to be figure number because it is independent. Y is going to be the dependent variable. It is the number of tiles, which depends on the figure number. So now that tells me where I'm going to put these numbers. 11 tiles in figure 4. That tells me that I'm going to have a figure 4 will have 11. And I'm leaving some space here because I'd like to put some other figures in. Figure 3, 2, and 1. And maybe I should move everything over further and also put in figure 0. So let's see, figure 3 has 8 tiles, so figure 3, 8 tiles. Hopefully that's what you remember for making tables. Now, do you notice the pattern? It's a linear pattern, because I'm telling you it is. Do you see the pattern in the table? Do you see how much it's changing by? It went up by 3, so to go backwards, we would go down by 3 to 5. And again, down by 3 to get 2. Down by 3 more to get negative 1. Now we have a complete table that represents the situation. Okay? And we see a growth in the table. Let's graph this guy on our graph. So we have the figure number 0 has negative 1. Figure 1 has 2. Figure 2 has 5, and so on. Just making a quick graph of the situation. So X represents the figure. I'm going to add some labels because that's a proper graph. Y represents the number of tiles. And we have a graph of our situation. And it is discrete, meaning we should not connect it because it doesn't make sense to have 0.5, a number between 0 and 1. So we don't need to connect this one. Okay? But we could continue our graph on, since we have more space if we wanted, and it keeps going. It grows by 3. Now that brings us to the rule. This is important that you remember this for next year. M, hopefully you all know that M is the slope. We do have a couple of ways to talk about slope. We call it change in Y over change in X. Remember, how much does it grow by? How much does it go up? And then how much does it go over? X and Y. Y is up and down. X is left and right. We also have called this slope growth because that just makes sense when we're talking about tile patterns. What's it growing by? Slope is a growth. It's just a fancy math term to talk about how quickly things are growing. The other value, B, we need to remember that that's the y-intercept. And we also call that the starting point. In this case, it's going to be figure 0. We always look at the 0 figure. So now we're ready to write our rule for this situation because we can see the growth. We already saw the growth of 3. And we know the y-intercept is -1 because of the graph. We know the y-intercept is -1 because we have this guy here. 0 is -1. And those are the two reasons how we can write the rule. And we can also check the rule and make sure it works for all of the values. So there's your first sheet to describe, to remind you of what M and B stand for and how to find them. One last thing we're going to add to the graph is that slope triangle, so we don't forget about this next year. Slope triangle, remember, goes up and over, and we went up 3 and over 1. I'll make that a little bigger for some of you that need it to be a little bit bigger. Let's see. So we went up 3 and over 1. So my slope, M, is 3 over 1, or 3. That's what we need to remember for next year because you'll be using that a lot when you get to geometry and even more when you get to algebra 2. Now let's take a look at our equation solving that we're going to do next. So, sorry, get this the right size for you. Solving linear equations. So I know most of you could whip out how to solve this real quick, but we're going to jot some notes down and we're going to talk about some suggested steps. Now there's no perfect way to solve every equation, but these are just reminders for things that you need to remember. The first thing you need to remember is what do we do first with this particular equation? Well, the first thing that we're going to do is parentheses. Because I need to take care of that to simplify it out. And I'm going to do that by distributing -4 times each of those. So the 2x is going to copy, but I'm going to do -4 times 3 to get -12. -4 times x to get -4x. That negative is really important. Everything on the other side just copies. Okay, that's our first move. It's a move that allows me to kind of work things out so I can simplify. Because the next biggest thing you'll do, if there's no parentheses, then you go on to simplifying each side. Now we look to the right side and we see it doesn't need to be simplified. It's already fairly simple. But on the left side, did you notice that the x's can be put together? So we should rewrite that as -2x minus 12. We simply simplified here. Now let's talk about our third step. Our third step is now to start moving things, okay? And we want to remember a couple of things. Legal moves are your key here. Now we're going to do some legal moves, doing things to both sides. I would recommend, again, this is a suggested step, that you move x's, or I should say any variables, together. It's a good idea to always get those guys together. So I'm going to do that as my first step. Doesn't matter which one I move, I'm going to move the 2x. But now I made a 0 pair here, which was my goal. I copied my -12, and I have -1x plus 2. Now after we move the variables together, our next legal move that I typically recommend is get the variables alone. If you remember when I first talked with equations at the beginning of the year, I often would say alone and together, and that's really the key here for all these problems. So get the variables alone. Okay. Getting the variables alone means I need to get rid of this 2, right? So I put the opposite on the board because it cancels the +2 with the -2, and I get -14 equals -1x. And remember, typically your last move is to divide. We usually divide at the end to get 1x because I want the -1s to cancel. I end up getting a single x alone, and -14 divided by -1 is 14. So now I've got my solution. Okay? So again, that last step is typically divide at the end. And again, this is not a perfect strategy. It's just something that you can use next year to remind you of how to solve equations. But it will not always be these exact steps because every equation is different. Thanks for watching. Hopefully you'll find use in these note sheets next year. Hang on to them. Just throw them in your book bag. Dig them back out in the fall. Have a great summer.